Okay, what if I told you that everything you've ever seen, every star, every galaxy, every planet, is really just the tip of a colossal cosmic iceberg? Well, we're about to go on a detective story to uncover the universe's biggest, darkest secret, a mysterious force that's been hiding in plain sight this whole time. So take a look at this. This chart tells a pretty shocking story. All the stuff we actually understand, everything we can see and touch, is just this tiny little slice right here, less than 5% of everything that actually exists. The rest? It's a complete and total mystery. That other 95%, that's what we call the dark universe, and it's basically a giant cosmic battlefield, a tug of war between two mysterious players. On one side, you've got dark matter, acting like the cosmic glue that pulls galaxies together. And on the other side, you've got our prime suspect for today, dark energy, the cosmic accelerator that's pushing everything apart. And right now, the accelerator is winning, big time. To really get what's going on, we've got to rewind the clock a bit, back to a discovery that completely turned our understanding of the universe on its head. This was the first major clue that something really, really strange was happening out there. You see, for most of the 20th century, scientists were in this huge debate about where the universe was heading. Einstein, at first, he wanted a nice, neat, static universe. Then along comes Edwin Hubble, who proves, nope, it's definitely expanding. So the big question became, okay, is gravity eventually going to slow that expansion down? Or maybe even pull it all back together one day? But then, in 1998, two completely independent teams of astronomers found something that just blew everyone's minds. The universe isn't slowing down at all. In fact, its expansion is speeding up. This was a total shock. It was like throwing a ball up into the air and watching it just accelerate into space on its own, completely defying gravity. It made no sense. So this shocking discovery led scientists to dust off a really old idea, one that became the prime suspect in our cosmic mystery, and pretty soon the very foundation of what we call the standard model of cosmology. The reading theory was this: empty space isn't actually empty. It turns out it might have its own built-in energy, a constant, unchanging energy that acts like a kind of anti-gravity. It creates this repulsive force, pushing everything in the universe apart. And this concept has a name: the cosmological constant. And here is the absolute best part, the ultimate irony. This idea, it was first dreamed up by Albert Einstein himself. But when he found out the universe was expanding, he threw it out, famously calling it his biggest blunder. Little did he know that decades later, it would come roaring back to become the cornerstone of how we understand the entire cosmos. Crazy, right? So for years, the case seemed pretty solid. Dark energy was this constant, unchanging force. But a massive new investigation has been digging up some evidence that, well, it just doesn't quite fit. And this is where our story gets a major plot twist. I want you to meet the Dark Energy Spectroscopic Instrument, or DESI for short. This thing is incredible. It is building the largest, most detailed 3D map of the universe we have ever attempted. It's meticulously charting the positions of millions upon millions of galaxies, looking back 11 billion years into cosmic history. And it's doing all of this to measure the universe's expansion with a level of precision we have just never had before. And all that incredible precision is helping us answer the one critical question that our whole mystery really hangs on. Is dark energy truly constant, like we've always thought? Or could it be changing over time? Because the answer to that question is where our cosmic detective story takes a very, very sharp turn. See, when you take DESI's ultra-precise map and combine it with other big cosmic measurements, a problem starts to emerge. Attention. Our standard model predicts that dark energy is a constant, unchanging force. But the combined data is hinting at something else. It suggests that maybe dark energy was actually stronger in the past, and it might be weakening over time. Now, in the world of physics, you need what's called a 5 sigma level of confidence to officially claim a discovery. That means there's only a 1 in 3.5 million chance your result is just a random fluke. These new findings, they're at 4.2 sigma. So while it's not technically a discovery, yet it's a huge crack in the foundation of our standard model. It's forcing scientists to seriously consider some other suspects. So, with our prime suspect in doubt, it is time to look at a brand new lineup of alternative theories. And let me tell you, some of these are pretty mind-bending. This new list of suspects is straight out of science fiction. You've got things like quintessence, which is this dynamic energy field that actually changes and evolves over time. Or maybe a unified dark fluid, some kind of Chimerian substance that acts like dark matter here and dark energy over there. Some theories even suggest that black holes are the source, that they're literally creating dark energy as they grow. And then there's the most radical idea of all. What if it's just an illusion? A cosmic mirage caused by our lumpy universe and some deep flaws in how we understand space and time itself. Now look, this isn't just some abstract cosmic puzzle for scientists to argue about. The answer to this mystery, whatever it turns out to be, is going to determine the ultimate fate of absolutely everything. If dark energy really is weakening, like this new data hints, then gravity could one day win that cosmic tug-of-war. It could stop the expansion and pull everything back together into a final, fiery, big crunch. But if dark energy is constant or gets stronger, then the universe faces something called the Big Rip, or a heat death. It just keeps expanding faster and faster forever until it becomes a cold, dark, empty void where even atoms themselves get torn apart. So that leaves us right here, at a pivotal moment in our quest to understand the cosmos. Our standard model, the guide we've used for decades, might just be wrong. And one of these wild cosmic suspects holds the key to reality as we know it. The cosmic secret is out there, hidden in the dark, and our journey to find it has only just begun.